Howdy guys, and welcome to another ESP32 technical tutorial. Now this one's been a while coming. There's been some challenges and good stuff, and we finally got our act together on this one. So what we're going to talk about is using a technology called Lib CURL, L-I-B CURL, C-U-R-L. Now let's start at the beginning on this. So first of all, we're going to talk about REST calls. Now a REST call is the ability to invoke a service over TCP/IP and the HTTP protocols. REST calls are basically the client-server technology that's displacing web services in the long run, and what it means is that from our ESP32 we can make a REST call to an external service provider. That service provider will receive the REST call, it will do some work on our behalf, and it will return a response. So in the ESP32 land, we might be, for example, making requests to look up a zip code or sending up some recorded sensor information. The bottom line is that sooner or later, you will be working with REST calls. There is no question of that. Now, a REST call is basically a request wrapped up in an HTTP protocol with a URL and a payload, and that's sent out over the internet, and we get a response back from a web server which is likely configured to perform some logic. Now, making REST calls is not difficult, it's not rocket science, but you have to do some work to form a connection to a web server and format the right protocols and build JSON data and send the data and check the responses and all kinds of other good things. Now, a very well thought of library was created some number of years ago called Lib CURL. Now, CURL, to be honest, I forget what CURL stands for, something to do with CURL probably, but the notion here is that Lib CURL is a very rich API for programming against REST protocol and a variety of other protocols, but I'm only going to focus on HTTP and the REST protocols in this story. So if I was a Unix programmer, a Linux programmer, a Windows programmer, or a Mac programmer, I could download and build libcurl on my platform, and then using the APIs described here from C, I could make these C API calls from my application and not have to worry about the mechanics of the underlying protocols, because curl takes care of all of those protocols on our behalf. So we need to only consider what it is that we want to achieve, the function we want to achieve, and curl does all the heavy lifting of building the network protocols and sending the requests and receiving the responses, including SSL/TLS support. So if we need to send things encrypted, my goodness, curl takes care of that as well for us. So the obvious question to us is, can we use curl, can we use libcurl in conjunction with our ESP32? And the answer is a solid yes. This would be a short video if the answer had been no, but the answer is a solid yes. So what we're going to look at in this story is, what does it take to download and build libcurl in or for an ESP32 environment. So let's go forth with that. Let's let me create a new. Let me find a terminal window, and we'll go ahead and we will create a whole new environment. So I've been practicing this a few times. So I've got a number of already built ones. So just to make sure I wasn't going to mess up. So let me create a new ESP32 project. And let me try and remember what my shell script is for creating a new ESP. There we go. New ESP32 app.shell, and we'll call this one libcurl4. Now this shell script, all it does is a git clone of the ESP32 template application. So if I now go into libcurl4, which didn't exist a few seconds ago, we've got our usual ESP32 template environment. Let's do the usual stuff of running a make config. I'm going to change my flashing speed up to 9200. This is just the usual stuff for building ESP32 applications. Okay, all done. Now let's do a make minus J5, and now we're just building, as is normal, our ESP32 template applications. Let's let that cook for a few seconds until it's done, and then we'll start to look at what it takes to build the curl library in order to use in conjunction with ESP32. Now the good news is there is a write-up, this URL, my ESP32 snippets, and these are the instructions we're going to follow. So you don't have to write these instructions down, they're all written down for us. Couldn't be much easier. So step number 1 is we're going to create a directory called components. Now this is all to do with the ESP32 ESP IDF build system. So if we go into our components directory, there's nothing here to begin with, but these are where new components are going to go for the ESP32 environment. So now in the components directory, we literally clone the normal, this is not a modified, but the normal latest version of the of the curl repository on GitHub. I run the paste there, and now what it's doing is it's downloading the latest code that is Lib CURL. So it's downloading that, it's having a think, yada yada yada, and we're done. Now, the curl code base is exceptionally portable. It will compile 100% cleanly on Linux, it will compile on Macintosh, it will compile on Windows, etc., etc. But you have to configure curl for those environments. You have to tell it what features are available in the operating system and what aren't, and from there it knows how to build itself properly. The secret sauce of this recipe is we have provided them in these directories in this project, so you don't have to worry about them yourself. So what you have to do is you have to copy these files from this repository into the correct place in the environment. So I am going to link my Eclipse environment with this new libcurl4 project that I just created so that we can copy things around within Eclipse. So I'm going to create libcurl number 4, hit the finish button, and all I did there, very simple, was give me a directory mapping into that file system. So I don't have to drag and drop from the Unix environment, I can drag and drop from Eclipse. So here is my clone somewhere here of my ESP32 project, and in there we've got the curl directory, and in here we've got the build files, in here we've got include curl, curl build. So that's number 1 of 3 files we have to move. So we copy that into the corresponding place in the include curl, right click, paste, and we've copied a file. We now have curl build. We go to the next one, and that is lib curl config, copy, and then down into here, lib, right click, paste, and we're done. And the final step is to take the component.make file, which is what drives the component mechanism, grab that and put that in the root directory of our new curl component, and we're done. Now, if I go back to my libcurl4 project and run make again, magic is happening. What is happening now is it's compiling the libcurl library that we downloaded from GitHub. We're compiling it through the ESP IDF build environment, and it's created the libcurl library. Now, literally, all we have to do is write ourselves C code that leverages the what do I want to say here? That leverages mine's gone blank. That leverages the curl APIs. So if we were to code a C program like this, ignore the errors there. Those are just because I haven't got my path set up right, but we can use the standard curl APIs and call those from within our ESP32 environment, and we are off to the races. We are running a curl environment. So now you can go study the curl API and you're good to go. You make these normal curl API calls, and I'm not going to teach you those. There's plenty of documentation on using curl, but now you can embed the curl APIs in your ESP32 applications. Excellent. Now I can stop here because this is what I wanted to show you. The docs are up on the ESP32 snippets. This is what the docs say. Clone this and copy these 3 files, do a build, and you're good to go. But I'm on a bit of a C++ kick these days. And one of the things that I've been working on is encapsulating a lot of ESP32 functions in C++ capabilities. And one of the things I've done is I've written this C++ class called RestClient that encapsulates the curl libraries. So now, without knowing any curl API, you can include this RestClient mechanism, specify the URL you want to go against, add any headers you want, specify any payloads, and you're off and running. So for example, here's a program I have already prepared. This is a C++ program. And what it does is it creates a REST client, sets the URL that I want to execute, specifies that I want to send JSON, send some data, and we see the result coming back. Now, if I run over to my ESP32 environment and run make monitor, that program runs, it starts up, it connects to my Wi-Fi provider, and then it calls out to the curl environment using HTTPS, just as it happens, and we get back a response from it after a few seconds, I hope, if all is going well, or not. Okay, well, I'm not going to show you that demo. Apparently that's not working. Could be that the backend service provider isn't particularly happy right now, but normally this works, and we make a REST call to the curl backend, and we get some data back. Just trust me that it works. It does work. It does work. And I'm going to pause here just to see if it eventually comes back. And yes, it did. Of course it did. About 20 seconds later. Now, the reason the timing is so slow here is we're using embed TLS, and the first time that makes a connection using SSL to the back end, literally can take up to 20 seconds. That's not good. Not my problem. That's another story. We'll look into what's going on there. But subsequent SSL requests come back lickety-split. So here I made an HTTPS request to that endpoint provider, passed in some data, and we got the response back. Really easy to encapsulate these things. Very simple stuff. So the core of the story here, let me recap one more time. We want to make REST requests. REST requests are the ability to send HTTP requests to the backend system. We can make REST requests by making raw sockets calls ourselves, but that's laborious, that's tedious. Thankfully, there's a great open source project called Lib CURL, and Lib CURL makes making REST and other protocol calls, including IMAP and mail and FTP and a whole variety of other things. So don't think this is just REST, but it makes them incredibly easy. The name of the story then is how do we build Lib CURL for the ESP32, and here's the recipe that I've come up with. It's not necessarily the only recipe, there might be others, but my goodness, this is about as quick and easy as it could be. And then when you've built Lib CURL, you can write your own ESP32C or C++ applications, and you're off to the races. And should you need, here's a sample C++ environment that shows us how to make REST client calls in C++ encapsulated at a very high level. I hope you found something useful in this tutorial, and I look forward to making more for you in the future, guys. Thanks now, and bye-bye.